In this video, I will show you how to determine if a relation is a function, and I will also help you to identify the domain and range of your graph. Now, to review, the domain is the set of all of the first elements of your ordered pairs, meaning x coordinates. So what we're going to do is list out all the x values that the graph, oops, I spelled values wrong. All the x values that your picture has, and the range is going to be all the set of elements, the second elements of your ordered pair, meaning your y coordinates. So this would be your y values. So this is your inputs and this is your outputs, and we're going to talk about the inputs and outputs you get from a graph. Now, domain and range can be very clearly seen from a graph. Domain comes from your x-axis, so it tells the spread from left to right of your graph. How wide is the graph? Where does it start on the left side? And where does it end on the right side? Or does it keep going to the left, or does it keep going to the right? I'll talk to you about those particular kinds of domain. The range is the height of the graph. How low can it reach and how high can it reach? So notice how this will talk about all 4 points of the graph. How left can it go, how right can it go, how low, and how high. Essentially, it's kind of like putting a rectangle around your graph, and your range talks about this dimension, your left to your right, and the range talks about the span or the height of your graph. So if you can put a box around it, that's what really your left and your right and your low and high come into place. So in this picture here, what I'm going to do is actually this one over here, identify for you the values that you get. Now the graph didn't print out super great, so I'm going to try to, as best I can, give you the dimensions of that graph. So it's really hard to see, but if the graph was printed a little bit better, this is 0, 1, 2, 3, 4, 5, 6, 7. So you can faintly see where the lines would have printed. They just didn't print very well. And so the leftmost starting point of my graph would be an x value of 1. And where it ends on the right would be a y value of 7. So the graph spans an x value, so on my x-axis from 1 to 7. This is how you would write it, domain. So because this is a continuous graph with no breaks in it, I'm going to use what is called a compound inequality to discuss that 1 to 7. And it will look like this. 1 to 7. So my inequality is going to talk about x in the middle because domain is your x values. And then range, we're going to do in a similar method, but we're going to have our y in the middle. Okay, so now as I'm looking at this same point here and here, now I want to span what's the lowest my graph can go. And it's really hard to tell because this picture didn't print so well, but this here would be a y value of 1, this would be a y value of 2, this would be a y value of 3. So the lowest the graph reaches is a value of 1, and it goes up to a high value of 3. So on the y-axis, it goes down to 1 and up to a height of 3. Now on this picture, domain and range of this function, if this is a line, I would assume, well, especially if it had arrows. This does not, but if it had arrows, then I would talk about domain this way. So if this arrow here points in this direction, that would mean that this graph continues to go on forever and ever. So this arrow implies that your graph is going up, but it is also going to continue to go to the right as it goes up. And this arrow would tell you that your graph is going down, and as it's going down, it's going to keep going left, keep going left, keep going left, and get wider and wider. So this says left. Now the left and the right are what your domain talk about, because your x-axis goes left to right. So this is, if this keeps going left, I'd put negative infinity. Now look at the symbol difference here to here. this symbol says equal to, and this one does not, because we can never technically equal infinity. So if this keeps going and going, I don't know what infinity really is, that number. So then I'll use strictly less than. And then if this graph keeps going to the right forever and ever, again, I will use infinity and not an equal to sign when we use the infinity symbol. Now range is the low to the high. So this graph will keep going lower, 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 lower. So negative infinity for my y values, and it will keep going. So this is the down that we just talked about. It will keep going up then, which would also be infinity. And notice how, again, I do not have the equal to like I did here, because this graph really did reach a low value of 1. Like it was equal to 1 down here, and it was equal to 1 here. Now, in these two pictures, we'll also talk about domain and range. For this picture here, this is called a parabola. It's a U shape that continues to go over here, down, and it will continue to go left. It will get wider and wider as it goes down. This also goes down, and it will continue to get wider and wider as it goes down, so that means it also continues to go right. Now, domain of a graph is going to talk about the leftness and the rightness of your graph. And if this keeps going left forever and ever, that would mean I would put negative infinity. And if this keeps going right, I would put infinity. Again, our symbols in our compound inequality should always open up to the right, and it should always go lowest to highest. And if this is left and it keeps going left, it is negative infinity. And if it keeps going right, it will be positive infinity. No equal to here, because we technically can't equal infinity. Now the range is the low of the graph to the high of the graph. Now this graph does have a high point. Now this point would be the point 0, 2, but range only discusses the y values of the point. So the y value of this point is the number 2, and that's the highest y value, that's the highest point in the graph. It's the highest y value here that we're tracking, the output. And then don't you notice here that we wrote that it's going to go down, 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 down? That would be negative infinity as a low y value up to the highest y value at 2. So the y values we're talking about range, and the x values are your domain. So left to right here in your domain, and low to high in your range. Now, this picture is also a parabola. This is the lowest point on the graph, and notice how this one goes up forever. So kind of similar to this, only we're going to talk about the shift here. This point, the lowest point on our parabola, is 0, 3. So for my range, for this graph, the lowest y value, because that's what this y is here, a 3, the lowest it reaches is a 3, also equal to here, because we do have that point. So equal to 3 is the lowest, and then up, 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 up forever, so I'm going to put infinity. Notice how we do have equality here for the 2, because that is a point on my graph, and 3 is a y value on my graph, so I put equal to here. Now for my domain, this graph is going to get wider and wider and wider and wider and wider and wider as it keeps going up. So because this goes up and it continues to go left, the left is really what I'm looking for here. So it's going to keep going left, which would be negative infinity if it keeps going that way. And this arrow would imply that it's going up, but it is also going to continue to go right forever, wider and wider and wider as it goes up. So that would mean negative infinity to infinity for your x values. Now I challenge you, there are 4 graphs for you to try on your own. See if you can try them, and then check out my next video to check your answers for domain and range for the next functions. And all of these are functions, every single one. So is the relation a function? Why would all of these be a function? I'm going to say yes, function here for all, because they all pass what is called the vertical line test, which is what we did, we taught in a previous video before this video. So vertical line test would pass every single one of these. So I'm just going to write it one time for all 4 of those graphs.